We are supposed to answer this question. Question 1. Suppose A and B are two independent events for which P of A equals 0.20 and P of B equals 0.60. Find A. Probability of A given that B. Probability of A given B. B. Probability of B given A. C. Probability of A and B. D. Probability of A or B. So let's look at making sense of what we've already done. Some solution. Solution. Sorry. P of A. P of A equals 0.20. This is probability of A, which is 0.0. So it's the probability of the event A occurring. It is 0.20. You have here probability of B occurring equals 0.60. Now we're supposed to find probability of A given B. So A, probability of A given B. Probability of event A occurring given that B occurs. So we have the formula for this probability of their intersection, that is A intersection B, all over probability of B. So the intersection between A and B, right? A and B all over the one that has already been given, probability of B. So let's come here. How do we even find probability of A intersection B? What wasn't given here, but we know that for independent events, right, as has been stated, A and B are two independent. That's the key word here. So for independent events, probability of A intersection B equals to probability of A times probability of B. Right, that's for independent events. So we have here P of A intersection B will give us 0.2 times 0.6, and this gives us 0.12. So now we can find, or we have found, probability of A intersection B. So let's solve our question. So P, probability of A given B, which was probability of A intersection B, all over probability of B, will be A intersection B is 0.12. So we have 0.12 all over probability of B. It has been given here 0.6, 0.6, and this will give us 0.2. So probability of A given B is equal to probability of the intersection between A and B. That is A intersection B all over probability of the one given, probability of B. We have 0.12 over 0.6. Probability of A intersection B wasn't given here, but we know the formula for independent events. That's probability of A intersection B is equal to probability of the first one A times probability of the second B. So we have it here. So let's come to B. Find the probability of B given A. And as we did in the first instance, it's going to be the probability of the intersection, that is B intersection A, all over probability of the second one, that's the one given, probability of A. But we know that But we know that probability of A intersection B is the same as probability of B intersection A. It is just the intersection, right? So this gives us probability of B given A will be probability of B intersection A or A intersection B, which is what 0 point, sorry, which is 0.12. So let me rewrite it so that you don't get confused. So I can write B intersection A all over probability of A, and this gives us 0.12 all over probability of A, which is 0.2, and this will give us 0.6. Right, so probability of B, you are finding the probability of B given A. This is going to be probability of the intersection B intersection A all over probability of A, the one given. But we know that probability of A intersection B is same as probability of B intersection A, right? So probability of B given A is equal to P, that's probability of B intersection A all over probability of A. You have 0.12 over 0.2 given us 0.6. So let's come to C. Find probability of A and B. When you have A and B, the N here means intersection. So probability of A and B is equal to probability of A intersection B. And you know, for two independent events, probability of A intersection B is equal to probability of A times probability of B, and this gives us 0.2 times 0.6, sorry, 0.6, and this gives us 0.12. We already did it here, right? So probability of A and B is the probability of A intersection B. And for two independent events, probability of A intersection B, A intersection B equals to probability of A times probability of B, which is 0.2 times 0.6, giving us 0.12. Now we come to D. We are finding probability of A or B, right? Probability of A or B. If I draw a Venn diagram, sorry, if I draw a Venn diagram, this is event A, this is event B. This portion here is A and this is B. This portion here is A intersection B. That's the common event, like something that is common to A and B. So that is A intersection B. But if I shade this part too, right? That is, I've shaded A only, B only, and that intersection. This is A or B. Probability of A or B occurring. That's the intersection with the only part two, right? So A only is this portion, B only is this portion, and this portion is the intersection. That is A or B. So probability of A or B is giving us, that's a union. Probability of A or B, A or B is equal to probability of A union B. which gives us probability of A probability of B minus the intersection probability of A intersection B. This is a formula, right? It can be quoted, it can be explained further, but for the purpose of this section, I'll just quote it so that you can use it. So probability of A plus probability of B minus probability of A intersection B. The whole of A is this, the whole of B is this, the remove the intersection, right? Because there'll be two portions of the intersection, so you have to remove one. That's how they're able to prove this formula and put it here. So P of A, is 0.2 and P of B is 0.6 minus the intersection, which is 0.12, and this gives us 0.68. So we've been given probability of A to 0.2, probability of B to 0.6, and we've been told that A and B are two independent events. Probability of A given B is probability of A intersection B all over probability of the one given, P of B. Probability of A intersection B equals to probability of A intersection B over this. But we know that for A intersection B and for two independent events, probability of A intersection B equals to probability of A times probability of B, which gives us 0.12. So you can take that in. You already know the probability of B. You substitute that and you get your answer. B is probability of B slash A. That's find the probability of B given A, which is probability of B intersection A all over probability of A. And probability of B intersection A is similar to probability of A intersection B, which is 0.12 over the probability of A, which is 0.2, giving us 0.6. Sorry, for C, we are supposed to find probability of A and B. And this is the same as probability of A intersection B. And as it was stated here, for independent event, probability of A intersection B is probability of A times probability of B, given as 0.12. D, probability of A or B is equal to probability of A union B. A and B is A intersection B. A or B is A union B, which is the probability of A plus probability of B minus intersection, which gives us 0.6.